So now on the board, we have a question under EMF or potential difference of a cell. It goes this way. So a battery made up of two cells. This diagram captures the question. So the battery made up of two cells. You see here, you can see the two cells with the diagrams. And they are joined in what? In one connection, in what? Series. These two cells are joined in series. Now, they say they supply current to an external resistance. Look at the external resistance of 5 ohms. This is the two cells, this is the external resistance. He said if the EMF and the internal resistance of each cell is 0.6 volts and 3 ohms respectively. As you say, the EMF of each of these cells is 0.6 volts. The same thing with the second cell, 0.6 volts. 0.6 volts for the EMF of this cell and 0.6 volts for the other EMF of the second cell. But they mention that these two cells also have internal resistance. All cells have internal resistance. So the internal resistance was not neglected. It was brought into question. Mind you, if you hear a question relating potential difference with currents, you can quickly use Ohm's law. V is equals to I R. But once the internal resistance is brought to question, you have to use the formulas we have derived earlier on. Now, I said, calculate the currents. Like I said, if you have not internal resistance was not mentioned, we have just said I is equals to V over R. But internal resistance of the cells are called into question. So we use the formula I is equals to EMF plus big arrow with external resistance plus internal resistance. But take note, the two cells are, we have two cells. So we have to get the total EMF, which of these they are connected in series. And to get total EMF in series, you just simply add their individual EMF. We have done it, which will be 0 plus 6V volts plus 0 plus 6 volts, which will give us 1.2 volts quickly. And we are done with the EMF, the total EMF, the equivalence EMF coming from the two cells. Now, what about the external resistance? The external resistance is given to the what? 5 ohms. 5 ohms. While the internal resistance, we have two cells. So one of the cells has its own internal resistance. The other what cell also has its own internal resistance. But the two cells are connected in what? Series. So the equivalent resistance, so get the equivalent resistance of the internal resistance of these two internal resistance. Because the cells are not connected in series, to get the equivalent internal resistance, you have to add them up with equivalent combination. You have to add them with series equivalent combination. Series equivalent combination. Now if you want to add two of more resistance in series, the equivalent resistance in series, you recall the formula, which is just simply to add them. Equivalence internal resistance. We just do 3 ohms plus 3 ohms, which is supposed to be R1 plus R2. Mind you, if these two cells get connected in parallel, if you want to go further and calculate the total internal resistance, you have to add resistance in parallel, which is not 1 over R1 plus 1 over R1 plus 1 over R2. It is because these two cells are connected in series. When we want to not get the total internal resistance, we just add it in what? Series combination, which is 6 ohms. With that, we can go back to this formula. We have this is small letter R. We can go back to this formula. This is E, big letter E. This small arrow, and this is internal resistance. So now that I is equals to E over arrow plus arrow. Our E is what? Yes, 1.2 volts. So we units. Arrow is what? Internal resistance is 5. While internal resistance, the equivalent internal resistance we came from the two cells was what? 6. This will now be 1.2 over 11. 1.2 over 11. If we should do that, 1.2 divided by 11, it will give us 0.11 to 2 decimal places. 0.11. What is the unit for current? The unit for current, as you know, is the SI unit is ampere. Because every other parameters or variables or quantity here are all in SI units. And what is the we should calculate again? To calculate the current flowing in the external resistor. This is the current flowing in the external resistor. That is the current flowing in the external resistor. Mind you, say the current flowing in the external resistor is still the same current flowing inside the cell and in the external resistor. That's why it was II, capital letter I, when we are dividing. So that's why we want to go to the next question, which says, part of the current, the next question is the terminal potential difference. Terminal potential difference, which was denoted with big letter V. Terminal potential difference, which was denoted with big letter V. Terminal PD. And the formula was still for Ohm's law was IR. Potential difference is equal to IR with big letter R, but this time around is capital letter R. And we have solved for this current. Nothing has changed. The current is 0.11 times the external resistance was what? 5, which will give us 0.55. And what is the unit we just calculate for potential difference? It is volts. Now, most of that question about the external potential difference, say the lost voltage. The lost voltage. The lost voltage. Lost voltage is small letter V. Small letter V. And it's for Ohm's law, it's R because the same current, but this time around it's internal resistance. The same current is flowing in external resistance that is also flowing inside the cell. So small V is equal to R, which will give us I is the same as 0.11. Our internal resistance, the equivalent internal resistance was what? Was 6. You multiply that, it will give us 0.66 volts. Now, back on this way, you can still go further in calculating V in another way, which we said was, or V is equal to E minus V. The small v is equal to E minus V. E minus V. E minus V. E minus V. E minus V, which is alternatively. E is equal to our E was 1.2, our big V was 0.55. If you subtract that, 1.2 minus 0.55, which will give us approximately 0.65 volts, which is the same thing. So there are alternative ways in getting lost voltage. Why? Because you are getting, because the formula was V is equal to big V, internal potential difference plus lost voltage. Now we have gotten our V already. We have gotten our E. So we make V our subject, small v, the subject of the formula, which we did here. Or we just solve it using Ohm's law, which also work for us in this case. We have another question on the board. Says a battery of EMF 12 volts and internal resistance 1.5 ohms. Quickly, your mind should just know that the internal resistance has been called to mind. So this battery with that volt and that internal resistance is connected to an external resistance of 3 ohms. So there's an external resistance of 3 ohms. External resistance of 3 ohms. If we have to draw this, it will be something of this nature. External resistance will be 3 ohms. We only have one battery. Now the internal resistance of the battery is 1.5 ohms. While the EMF of the battery is given to the 12 volts. So this picture illustrates what is given. Now it says calculate the current flowing, calculate the current flowing in the circuit. Now, if internal resistance was not called to mind, we would have just used Ohm's law, V is equal to I, and make I the subject of the formula, which will be I is equal to V over R. But internal resistance of this battery has been called to mind. So the formula we are going to use, it will now be I is equal to E R, big letter R plus small letter R. We know that EMF of the cell was given to be 12 volts. EMF of the cell is given to the what? 12 volts. While the external resistance was given to the what? 3 ohms. While the internal resistance of the battery was given to be 1.5 ohms. Plugging each value into the formula, we arrive at E12 plus 3 plus 1.5, which will give us 12 over 4.5. 12 divided by 4.5 will give us 2.67. 12 divided by 4.5 will give us 2.67. So 2 decimal places. What are we calculating for current? So the unit, SI unit, will be ampere. And that is the current flowing through the external resistor, which is also the current flowing in battery. Now, it's a current flowing in the circuit. Okay, the other part is the potential drop across 3 ohms. What is the potential drop across the 3 ohms? So you are looking at the resistance drop in this resistor, the potential drop across these 3 ohms. So you are not concerned about the internal resistance. You are only, the first part is draw the potential drop across these 3 ohms. So we still use the formula V is equals to I arrow. The arrow is the resistance of this external resistor. And this current, see the same current flowing over there. This V is not the potential drop in this what? External resistance. So I'm looking for V. V is equals to I is what? 2.67 times. While our arrow is what? Still 1 times that. We get V is equals to what? 8. V is equals to approximately 8 volts. Approximately 8 volts. Now that big part of the question is not just the potential drop across the 3 ohms resistor, and the internal resistance. So you are still looking at the potential drop across the internal resistance. Potential drop across the internal resistance, which we denote as small letter V, will not be from Ohm's law, will not be still that same but this time the internal resistance. Good. Now our which will not be small v is equals to I was 2.67 approximately, while arrow the internal resistance was 1.5. 1.5. Which will give us V is equals to 4 volts approximately. Good. And that is that. Now the C part says the terminal voltage of the battery. So this question, like I said, is just playing around. What is now the terminal voltage of the battery? Terminal voltage of the battery. It is still the same thing as the potential drop across the 3 ohms resistance. The terminal voltage of the battery, because the terminal potential difference, we just say the potential difference across the what? External resistance. Terminal potential difference was still the what? External, was the potential difference across the external resistance. So this is what we have calculated. So we just write it as terminal voltage is equals to 8 volts. Alternatively, you can still use from E is equals to big V plus small v. You can make big V the subject of the formula. To now this one E minus small v. E was given to be 12 minus small v was, we got it as 4, which will still give us 8 volts. So be careful and know what you are doing. The standard voltage of the battery was still the potential difference across the external resistance. While the last part of the question says the reading of a voltmeter connected across the battery terminal in an open circuit. So if you break the circuit, now you should put a key and break the circuit. What will now be the reading of this battery when it's in this open circuit? The reading of the battery, the reading of the voltmeter. No, voltmeter is the device for measuring what? Potential difference or EMF, depending on how specific you are. Now you are talking about voltmeter. Now you are looking at the you are using voltmeter to measure this what? You are using voltmeter to measure, get a reading of this battery when the circuit is what? Open. You are using a voltmeter to get a reading of this cell when the circuit will be open. Now from your knowledge, what you are following, what do you think will be the reading of the voltmeter of this cell when it's in an open circuit? Cool. Definitely, because it's in an open circuit, the voltmeter will give you the direct reading, which will be the EMF of the what? Cell. And the EMF of the cell is given to the what? 12 volts. Because it's in the open cell. We have earlier defined EMF as of a cell as the potential difference of the cell across its terminal. The potential difference across the terminal of the cell when it is in an open circuit. So the voltmeter will just give you the EMF of the cell. You do not be concerned about the internal resistance because the cell is connected in an open circuit. So the reading of the voltmeter will be the EMF of the cell in which it was designed. So D will be reading of voltmeter. The reading of the voltmeter one more time will be the EMF of the cell, the way it was designed, when it is in an open circuit, which is given to be 12 volts. You will not be interested about the internal resistance and the external resistance to influence the what potential difference or the EMF of the what cell. Let's take one question under this. Let's take a question under this. Let's take a question. So this question says a voltmeter of 800 ohms. A voltmeter of 800 ohms resistance. So the voltmeter, the resistance of the voltmeter is 800 ohms. One thing you must understand is that a conductor as a material has its own resistance. When you want to test, when you want to make reading, get readings using your devices such as voltmeter, these devices may also have their own resistance, they also have their own resistance. Loads, that is a major component in a simple circuit, also have its own resistance. But the resistance found inside the battery is what we now call the internal resistance. All the other resistance, apart from the resistance found inside the cells, we refer to them as a family of external resistance. So this voltmeter of 800 ohms is not like external resistance, the big letter R. The big letter R. And this R is equals to 800 ohms. Now, he said he gave a reading of 180 volts when connected across a battery. So they use it to read a what battery, and he gave a what potential difference of 180 volts. Is that the EMF of the battery? No, it is not the EMF of the battery, because we are not told that the battery is in an open circuit. So this reading the voltmeter is giving is just like the terminal potential difference in the external resistance. So this 180 volts is now for what? 180 volts is now for what? Big V, terminal potential difference across this is own external resistance, because we are considering the resistance of just the voltmeter. No resistor was said to be replaced in this circuit. Now he said across a battery of 30 ohms. Again, this battery's internal resistance is called to question. Internal resistance is small letter R, which is 30 ohms. Now we are asked to calculate the EMF. E is equals to question mark. Now, once again, somebody has said the voltmeter, because they connected it to the battery, the reading is getting 180 volts, supposed to be the EMF. But no, it is not told to be an open circuit. It's not told to be an open circuit. Only when it is an open circuit, the reading you are getting will now be that of the EMF of the battery. Now, because internal resistance is called to question, we still use our formula I is equals to E over big arrow plus arrow. We are looking for what? E. We are looking for what? E. But we have big letter arrow, we have small letter arrow, but we don't see our arrow. So I will go ahead to get our arrow. I will go ahead to get our before you get E, our EMF. Now you know from terminal potential difference, but terminal potential difference is big letter I over arrow. The current flowing through the voltmeter, and the resistance that is found in the voltmeter. There is a resistance that is our external resistance in this question. The resistance of the voltmeter, that is our external resistance, and the current that is flowing through it, we are interested in it. So I, making the subject of the formula will now be V over R. R is equals to V over R, big R. Our V is, the reading was 180 volts, which is the potential difference across the battery, over R, big R, which is the resistance of the voltmeter, which is big R. Big R was 800. When you do that, it will be 0.225 ampere, 0.225 ampere, 0.225 ampere, 0.225 ampere. Now that we have a current, you can go down to this formula where E is I is equals to E over R plus R. Making E the subject of the formula, we have that E is equals to R times bracket R plus R. Now E is equals to R is what? 0.225. Our big letter R is 800 plus our internal resistance is 30. Now we should know E is equals to 0.225. If you add this, it will be 830. Now 830 times 0.225 will give us 186.75 volts. That will not be the word EMF of the cell. That will not be the EMF of the cell. So we have advised you to come around and play with questions under this topic.